Hello everyone, how to solve this problem for the values of k if we have k square minus k cubed is equals to 36, and we solve this problem for all the values of k. So here we find all the roots or all the solution of this equation. So I hope so you like this method, but if you have any other method in your mind, so please don't hesitate to write this method into the comment section. So here I can just use the factorization technique to solve this problem or to solve this cubic equation. So I hope so you already know about that. There are many ways to solve this cubic equation, in which some ways are you can just use here synthetic division, or you can just make the factors of this equation to solve the values, to solve the solution of this equation, or to find the values of k. Okay, so here we need to focus into the right hand side, and in the right hand side we have this is 36, and we break over this 36 as 27 plus 9. We know that 27 plus 9 becomes here 36. So further in the next step we have this is k square minus k cubed is equals to, here we have 27, and we write this 27 as 3 cubed, plus we write this 9 as 3 square. So here we move both of these two terms from right hand side to the left hand side, and it will becomes k square minus k cubed, and this is plus 3 cubed becomes minus 3 cubed. This plus 3 square becomes minus 3 square, and this whole equation is equals to 0. And now here we need to make the pair of square term with square term and cubic term with cubic term. So here we have the square term is k square, and this is minus 3 square, and from both of these two terms we will take common negative sign, and we get k cubed and plus 3 cubed, and this whole equation is equals to 0. So here we use the nice two formulas to solve this equation. So here first we use this nice square identity. You know about that. If we have a square minus b square is equals to a minus b times of a plus b, and second we use here this nice cubic formula. You know about that. If we have a cubed plus b cubed is equals to a plus b times of a square minus ab plus b square. So here when we apply here this square identity into the first term, it will be written as in this form. First we have this is k minus 3 times of k plus 3, and minus, here we apply this cubic formula, and after applying this formula it will be written as this is k plus 3 times of this is a square minus ab. The value of a is k square minus k times of 3 plus 3 square, and this whole equation is equals to 0. And further you see here both of these two terms involve k plus 3, so that here we take common k plus 3, and when we will take common k plus 3 we get the remaining values are, from here we get k minus 3, and here we need to multiply this negative sign on each of these values, and it will becomes minus k square plus 3 times of k, and this is minus 3 square becomes 9, and this whole equation is equals to 0. And further in the next step we have this is k plus 3 times of, here we have minus k square, and this is k plus 3k becomes 4k, and this is minus 3 and minus 9 becomes minus 12, and this whole equation is equals to 0. And now we divide this equation into the two cases. The first case is we write k plus 3 is equals to 0, and the second case is we write minus k square plus 4k minus 12 is equals to 0. So from first case we easily get the value of k is equals to minus 3. This is the first solution, and from here in order to get the other solution of this equation we need to solve this quadratic equation. But you see here this equation is not into the standard form, so in order to write this into the standard form we need to multiplying both of the sides by minus 1. So when you multiply each of these terms both of the sides by minus 1, it will be written as k square minus 4 times of k and plus 12 is equals to 0. So because this is quadratic equation, and we have there are three methods to solve the quadratic equation. The first one is factorization method, second one is completing square, and third one is by applying the quadratic formula. So here we use the quadratic formula to solve this quadratic equation. So for applying the quadratic formula, first we need to write the coefficients of this equation, and its coefficients are A is equals to 1, B is equals to -4, and C is equals to 12. And here we state the quadratic formula as k is equals to minus b plus minus square root of b square minus 4 times of ac divided by 2 times of a. This is the our quadratic formula, and now here we need to substitute the values of a, b, and c here. So we have k is equals to, this is minus b, the value of b is minus 4 plus minus square root of b square. B is minus 4 square, minus 4 times of a is 1, and c is 12, and it is divided by 2 times of a, and here our a is equals to 1. So we have, this is minus times of minus becomes plus 4, and plus minus square root of minus 4 square becomes 16, and this is 4 times of 12 becomes 48, and it is divided by 2 times of 1 is equals to 2. So here when we subtract these two values, it will be written as k is equals to 4 plus minus, this is square root of 16 minus 48 is equals to minus 32, and it is divided by 2. So further we need more simplifications, and here we need to first apply square root sign separately on both of these values, and it will be written as 4 plus minus, this is square root of 32, and we write 32 as 16 times of 2 into square root of minus 1, and it is divided by 2. So here when we apply square root sign separately on both of these values, it will be written as 4 plus minus, we know about that square root of 16 becomes 4 times of square root of 2 into, this is square root of minus 1 equals to iota, and here we need to break this value, we break this fraction, and it will become 4 divided by 2 plus minus 4 times of square root of 2 iota is also divided by 2. So we cancel this term, this is 2 times of 2 is 4, and we get k is equals to 2 plus minus, this is 2 times of 2 becomes 4, and we get 2 times of square root of 2 into iota. So this is the second value of k. So here we get, these are the two complex roots of the given equation, and we have k is equals to minus 3 be the one real root of the given equation. So these are the three solutions of the given equation which we get here in this method, and this is our final answer. And thank you so much for watching this video. Please subscribe to my channel for more exciting videos.